On October 14th, 1943, 291 B-17 flying fortresses climbed into the frozen skies over occupied Europe. Nearly 3,000 men were on their way to bomb the ball-bearing factories at Schweinfurt, Germany. This was the second time the 8th Air Force had attacked Schweinfurt. The first raid 2 months earlier had been terrible. 36 bombers were shot down, hundreds of men died, or were captured. Survivors came back with stories of German fighter attacks so strong that some crews ran out of ammo before reaching the target. They said German fighters waited in the distance like cars at a toll booth, taking turns to attack the American planes. Schweinfurt made ball bearings. Ball bearings were needed for almost every German weapon. Tanks needed them, planes needed them, submarines needed them. American leaders thought that destroying the ball-bearing factories would stop Germany from making weapons a target was worth any cost. The crews knew what was coming. They had seen the empty beds in their barracks after the first raid. They had attended memorials for men who were joking at breakfast, but dead by dinner. They knew the odds. Still, they climbed into their bombers at 25,000 feet. The temperature outside was minus 50 degrees Fahrenheit. Inside the planes, it was almost as cold. B-17s had no heating and no pressurization. Thin aluminum walls carried the cold into crew areas like a fridge. Frost formed on the windows. Breath froze on oxygen masks. Metal was so cold that touching it with bare skin caused instant frostbite. The waist gunners had it worse. They stood at open windows on the sides, firing 50 caliber guns into the 200 miles per hour Arctic wind. Wind chill made it even colder, reaching levels a human body could not handle, even with heated suits and thick clothing. These men risked freezing. In less than a minute, every man wore a heated flight suit, a one-piece coverall with wires sewn in to keep them warm. The suits plugged into the plane's electricity. They were supposed to keep men alive at high altitude. But the suits had a design flaw. Wires broke, heating circuits failed. Men who were warm one moment were suddenly exposed to deadly cold with no fix. German fighters and anti-aircraft guns made the day even worse. 60 bombers were shot down. Over 100 were damaged, some too badly to ever fly again. More than 600 men were killed, wounded, or captured. This mission became known as Black Thursday, one of the darkest days in American air history. What the survivors didn't know yet was that the cold itself was killing even more men than German guns. Not as fast, not as obvious, but just as deadly. By December 1943, 1634 men will be taken off flying duty because of cold injuries. Sustained on operational missions during the same period. 127 men were removed because of wounds from enemy action. The cold was killing more American airmen than the Luftwaffe. This is the story of how America tried to beat German fighters at high altitude and accidentally froze its own pilots to death. It is the story of bureaucratic failure and the heroism of engineers who had never seen combat, designing equipment for men who would die, using of a surgeon who had served in the trenches of World War I and refused to accept that good men should keep dying from preventable causes. And it is a story of how lessons learned in frozen agony over Germany would reshape military aviation for generations to come. The problem began with a fundamental miscalculation about the nature of aerial combat over Europe when Boeing designed the B-17 Flying Fortress in the mid-1930s. Engineers in sunny California imagined a strategic weapon that would fly higher than enemy fighters, could reach the bomber's service ceiling, exceeded 30,000 feet. At that height, anti-aircraft guns lost accuracy because the shells took too long to reach the target, allowing bombers to move unpredictably. Fighter planes struggled to climb high enough to intercept, and those that did had engines starved for oxygen. Their controls were sluggish in the thin air. The high-altitude strategy made sense. Flying above the threat meant surviving the bomb. Another day, American war planners built their entire strategy around this idea. Formations of heavy bombers would fly in tight defensive boxes. Their overlapping machine gun fire would create a wall of bullets that enemy fighters could not penetrate. They would bomb from above the worst offenses and return home mostly intact. The theory was elegant, but the reality was catastrophic. The designers had never faced what their crews would experience. They had calculated the bomber's performance at altitude, but had not fully considered what the altitude would do to men inside. At 30,000 feet, air temperature drops to 60 degrees below 0 Fahrenheit. At 25,000 feet, where most combat happened, temperatures average 40 to 50 below human flesh. Exposed to that cold, freezes in less than 60 seconds. Bare metal becomes so cold that touching it causes instant frostbite. Breath freezes before Leaving the oxygen mask, the B-17 carried a crew of 10 men spread through an unheated, unpressurized fuselage. The pilot and co-pilot sat in the cockpit at the front, relatively protected, but still exposed to bitter cold. The bombardier and navigator were in the nose compartment below them, surrounded by plexiglass that offered great visibility, but almost no insulation. The flight engineer manned the top turret behind. The cockpit, the radio operator sat in the midsection. 2 waist gunners stood it open. Windows on either side of the fuselage. The ball turret gunner crouched in the spherical turret beneath the aircraft. The tail gunner sat alone in a cramped compartment. At the very rear, every position was cold, but some were deadly cold. The waist gun positions were open to a 200 miles per hour wind through the windows. The original design left the windows uncovered, so gunners could move freely to track attacking fighters when enemy planes attacked from the sides. Waist gunners leaned out into the freezing blast, turning their heavy guns to follow targets coming at over 500 miles per hour. No clothing could protect them from that kind of cold. At 200 miles per hour in minus 50-degree air, the wind made it feel far colder than humans could survive. Even brief exposure caused frostbite. Longer exposure could cause permanent injury. The ball turret was worse in a different way, made by the Sperry Corporation. It was an amazing piece of engineering, but a nightmare for exposure. The spherical turret was about 4 feet wide, just big enough for a man in a fetal position. With a 50 caliber machine gun, ammo feeds a reflector sight and the rotating mechanism. There was no room for a parachute or extra clothing. Only the smallest men could fit. Regulations limited ball turret gunners to under 5 foot 6 inches, and 150 pounds. A turret was made of plexiglass and aluminum that offered no insulation. Cold came through every surface. A gunner sat with knees to chest, hands on control handles that got so cold they could freeze. Through gloves, feet rested on pedals that became blocks of ice, back pressed against the turret shell, which carried cold directly into the body. If the heating suit failed, the gunner had no way out. The turret had to be rotated to a certain position. To climb out in rotation needed electricity. If battle damage cut power or jammed the mechanism, the gunner was trapped. If the suit failed, he would freeze. Most ball turret gunners whose suits failed stayed inside. They knew leaving would endanger the plane and crew. German fighters often attacked from below. A fighter from underneath could hit the bomber before top, or waist guns could respond. The ball turret gunner was often the only defense. Leaving meant leaving the crew exposed. So they stayed. They kept hands on the controls, tracking the sky for fighters, even as cold crept through their bodies. As the plane climbed, the turret got colder. At 22,000 feet, it was 30 below zero. At 25,000 feet, it was 40 below. Cold went through the plexiglass dome, the aluminum, and their leather gloves. Fingers went numb first, and hands and forearms. The numbness rose like water in a tub, but they kept their hands on the controls, watching for enemy fighters. They kept doing their jobs until the plane landed, and someone could help them out. The turret flight surgeons who treated these men after missions sometimes had to cut the gloves off with scissors, because frozen fingers could not bend the flesh. Underneath was white and hard. Many lost fingers, some lost entire hands. All of them had done their duty to the very end. The tail gunner sat completely alone at the back of the plane, separated from the crew by the fuselage and surrounded by cold that moved around the tail surfaces and into his compartment. He could only communicate by interphone if his oxygen system failed or his heating suit died. No one could help. He would simply freeze alone while the rest of the crew kept flying until they landed and found him. The first bombers of the 8th Air Force arrived in England in the summer of 1942, ready to show that daylight precision bombing could win the war. What they found instead was that their own planes were killing crews before the Germans could. Colonel Malcolm Groh had seen combat before, and he knew what it did to men and organizations. As a young surgeon in 1915, he went to Tsarist Russia and volunteered with the Russian army on the Eastern Front for 2 years. He operated on wounded soldiers while German artillery shells exploded around the field hospital. He worked in conditions that would have seemed impossible to American medical professionals at the time, improvising surgical techniques and treatments under fire. The Russians recognized his courage and skill. He earned the Order of St. George for bravery under fire, one of the highest decorations Imperial Russia could give a foreign officer. He also received the Order of St. Stanislaus for his surgical work. His 1918 memoir, Surgeon Groh, an American in the Russian fighting, documented these experiences and made him one of the few American military medical officers with frontline combat experience. In 1917, after the Russian Revolution made his position impossible, Groh returned to the United States and joined the Army. He spent the years between wars learning a new field, aviation medicine. He earned his aviation medicine certificate in 1928 and helped create the Aeromed Laboratory at Wright-Patterson in Ohio. By the time the United States entered World War II, Grow was one of the most experienced aviation medicine specialists in the military with both combat experience and deep knowledge of the physical challenges of flight. General Carl Spaatz was building the 8th Air Force in England and needed a surgeon who understood combat and aviation, someone who could handle mass casualties, someone who could work under wartime conditions, someone who could find solutions when standard procedures failed. Malcolm Grow was the obvious choice. He arrived in England in 1942 and began studying the medical challenges of high-altitude bombing missions. These problems were unlike anything American medical science had seen. Ground combat caused injuries from bullets and shell fragments that doctors knew how to treat, but high-altitude bombing caused something different. It caused cold injuries. The first frostbite cases came back from early missions over occupied France. Waist gunners with blackened fingers, tail gunners whose ears were white hard and numb, bald turret operators who could not feel their feet when they climbed out after landing. These men had not been hit by enemy fire, but were just as badly hurt. The injuries were serious enough to ground experienced crews. Men, the 8th Air Force desperately needed training. A bomber crew took months. Combat experience took even longer. A pilot might have hundreds of flight hours, but combat flying was very different from training. A gunner might have practice on ranges, but shooting at towed targets was nothing like shooting at fighters that were shooting back. Every man lost to frostbite left a gap in the crew that could not be easily filled. Grow studied the casualty reports with growing concern. A pattern was clear. Men were getting frostbite even while wearing the protective gear the Army issued. They followed procedures, they used their equipment correctly, and still froze. The equipment was supposed to work. The specifications said it would protect against high-altitude cold. The manufacturers had tested it, procurement officers had approved it, but the specifications were wrong. The electrically heated flight suit was supposed to solve the high-altitude cold problem. The idea went back to 1918 when the Army Air Corps first experimented with electric heating for aviators in open cockpit biplanes. Development continued to the 1920s and 30s as planes could fly higher. By 1941, the standard heated suit was the F-1, made only by General Electric and standardized on April 4th of that year. The F-1 was a one-piece coverall made of felted wool with heated wires sewn in a blanket pattern. The suit plugged into the aircraft 24-volt electrical system with a 2-pin connector. Power flowed through the wires, creating heat like an electric blanket. Pilots and crew called it the Blue Bunny because of its light blue color. When it worked, it could keep a man comfortable at 30 below zero priority. When the tail and ball gunners who were in the coldest positions, waist gunners got suits if the plane's electrical system could support it. The B-17 was the only bomber with a 24-volt system, so only B-17 crews could use Blue Bunny suits. The idea was good electrical heating could give warmth without heavy insulation that restricted movement. A man in a working heated suit could operate weapons without bulky Arctic gear. He could track targets smoothly, use controls precisely, fight effectively at high altitude, but the execution was a disaster. The F-1 suit had a fatal design flaw. That testing in the American Southwest had not revealed the heating wires were connected in series like old-fashioned Christmas lights. Electric current flowed through each wire in order from one end to the other. If every connection stayed intact, the suit worked perfectly. Current flowed smoothly through the fabric, heating it evenly. But if one wire broke anywhere, the whole system failed. No current could pass to break the suit when completely cold instantly with no warning. One moment a man was warm, the next he was exposed to deadly cold with no protection. The wires broke constantly. The felted wool fabric shifted as men moved, stretching the wires. Gunners twisted and turned to track enemy fighters, crouched and stretched to clear jammed weapons, climbed in and out of tight spaces. They moved in every way combat required, and every motion stressed the fragile wires. The testing in the American Southwest had not shown this problem because it did not replicate. Combat men in test environments moved carefully. They did not twist, dive, and scramble while German fighters fired at them. The wires held up to careful movement, but not to combat a man at 25,000 feet over enemy territory. With FW-190s making firing passes, would suddenly find his suit stopped working. Warmth would vanish. Cold would start seeping through his gear. He had minutes, maybe 15 or 20 if lucky, before frostbite began destroying his hands, and there was nothing he could do. He could not find the problem. He could not fix the break. He could not Even Tell Which Wire had failed an Army investigation in March 1943 showed how bad the problem was. Electrically heated garment failures caused about 3/4 of frostbite casualties from equipment. The suits failed faster, then they could be replaced faster than crews, could adapt faster than new equipment, could arrive. The Blue Bunny was supposed to save lives. Instead, it caused casualties. Colonel Groh collected statistics that told a story the Army Air Force leadership did not want to hear. In the 14 months ending December 1943, frostbite removed more men from flying duty than German fighters, and anti-aircraft guns combined. The cold was a more effective weapon than the Luftwaffe. A third of frostbite cases needed hospitalization. Many men would not return to duty for months. Some would never return at all. You cannot regrow amputated fingers. Frostbitten feet with lost circulation do not heal quickly or fully. Men who survived German fighters and flak were being permanently disabled by their own equipment. The 8th Air Force was losing trained crews faster than replacements could be trained and sent across the Atlantic. The training pipeline could not keep up with losses. Experience was leaving the squadrons. Every time a veteran gunner lost fingers to the cold, the enemy causing most of the damage was not German fighters or anti-aircraft guns. The enemy was the temperature at high altitude, the failed heating suits, the open windows in the waist gun positions, and the inadequate equipment and training that no one had foreseen would become a crisis. Groh presented his findings to commanding officers. The response was a mix of frustration, denial, and bureaucratic paralysis. The heating suits were supposed to work the specifications, said they would function at high altitude. The manufacturer said they had been tested. Procurement officers who bought thousands of these suits insisted they met all requirements, but specifications meant nothing when wires broke inside the suits. Manufacturer claims meant nothing when men were losing fingers. Procurement paperwork meant nothing when Blue Bunny suits failed mission after mission. Groh pushed harder. He asked for resources to study the problem. He asked for authority to develop new solutions. He wanted engineering help to redesign the heating systems. He needed manufacturing capacity to make improved suits. Once designs were finished, the bureaucracy moved slowly. Requests sat on desks waiting for signatures. Approval chains stretched across the Atlantic to Washington. Officers who had never flown combat argued about whether the spending was necessary. Paperwork disappeared in the files and was forgotten. Meanwhile, men kept freezing. Wind blast was the largest cause of high-altitude frostbite, responsible for 39% of cases in the 14 months ending December 1943. By 1944, had risen to nearly 55%. The problem was simple physics. Air moving at 200 miles per hour strips heat from a human body faster than any heating system could replace it. Even a perfectly working heated suit could not stop the heat loss. When a waist gunner leaned into the slipstream tracking and attacking fighters, clearing jam guns caused another deadly problem. A 50 caliber machine gun could jam at any moment. The gunner had to clear the jam, or his weapon was useless. Clearing a jam meant working the gun's charging handle, a metal lever that had to be gripped and pulled hard. Training manuals said this could be done with the heavy leather gloves. Crews were issued the manuals were wrong. The gloves were too bulky for precise work. A man could grip the handle and pull the trigger, but could not fix the fine mechanisms needed to clear a jam. Gunners across the 8th Air Force learned this in combat. When guns jammed and enemy fighters attacked with seconds to fix them, they pulled off their gloves, gripped frozen metal with bare fingers, cleared the jam, saved their aircraft and crew, and lost fingers. Flesh froze on contact with metal, chilled to 60 below zero. 15 seconds was enough for permanent damage. 30 seconds could mean amputation. Casualty reports noted these men had broken proper procedure by removing gloves. Regulations clearly stated that gun malfunctions should be cleared with gloves on. The bureaucracy blamed the men, but the regulations did not work. Everyone knew they did not work. Everyone who had actually flown combat knew the choice was between losing fingers or losing the aircraft. The men did what they had to do, because the alternative was death. Ground crews watched bombers return with injured men. They saw frostbite casualties carried to ambulances. They heard the stories in mess halls and barracks. They knew something was very wrong. Master Sergeant Earl Southwick was a crew chief with a 398 Bomb Group 63rd Squadron. His job was to keep his assigned B-17 flying no matter what damage it returned with, no matter what systems had failed. Southwick worked long days in the cold and rain of an English winter. He patched battle damage with sheet metal and rivets, replaced engines shot out over Germany, fixed hydraulic lines, electrical systems, oxygen regulators, and 1,000 other parts that could fail in combat. He understood the difference between official specifications and operational reality specifications, said certain repairs needed depot-level maintenance, meaning the plane had to be sent to a rear area facility. Specifications said some modifications required engineering approval from the manufacturer, meaning paperwork that could take weeks or months, but depot maintenance made an aircraft unavailable for combat for long periods. Engineering approval often disappeared into bureaucratic black holes the 8th Air Force needed every bomber it could fly. There was no time for proper channels. Southwick's assistant Dallas later wrote that if this repair had been made stateside, I could have been court-martialed, but this was a different time and place. We had to do what was needed to keep planes in the air. The three-man crew of Southwick E.B. Best and Fred Whitman maintained their B-17 so well that none ever turned back from a mission because of mechanical problems. Southwick received the Bronze Star for this achievement. Ground crews improvised across the theater. They made parts not available through supply. They did repairs at regulation, said only depot facilities could attempt a modified aircraft to fix problems the designers never anticipated. The same improvisation drove efforts to reduce frostbite at the squadron level. Mechanics added insulation to gun positions, rigged extra electrical outlets for heated gear, wrapped heating elements in protective covers to prevent wire breakage, but field fixes could not fix systemic failure. The heating suits were designed wrong. The waist gun windows were open to the slipstream. The whole idea of operating in extreme cold had not been properly considered. Individual effort could not fix systemic problems. The 8th Air Force needed solutions from the top down, developed by engineers and applied across the entire force. Colonel Grow knew the frostbite crisis needed a systematic response. Individual courage and improvisation could not overcome bad equipment and poor training. The Army Air Forces needed new solutions developed by experts and put into action on a large scale. Grow began working on several fronts at once. Better suits that would not fail, better training, so crews understood the dangers, better protective gear for specific vulnerabilities, modified aircraft designs to reduce crew exposure to deadly cold. The heated suit problem was the most urgent. Gross investigation had found the core flaw in the F-1 design. Wiring the heating elements in series meant that a single break anywhere shut down the entire suit. The solution was simple to anyone who knew basic electrical engineering. Why not wire the elements in parallel? In a parallel circuit, each heating element works independently. Electric current flows through multiple paths. If one wire breaks, the rest still works. A man might lose heat to one part of his body, but would not lose it everywhere at once. Parallel wiring also allowed redundancy. If the suit had two independent circuits, a break in one left 50% of heating functional. A man with half the suit working could survive far longer than a man with no heat. Grow pushed these requirements through procurement. General Electric developed a new suit using parallel wiring. The F-2 electrically heated flying suit was standardized in August 1943. The new suit was very different from the Blue Bunny. Instead of one piece, it had four main parts: an electrically heated jacket and trousers, an unheated outer jacket and trousers. The modular design let crews replace a component if one piece failed. Instead of discarding the entire suit, the heating elements used more flexible wiring that resisted breaking. Connections between parts were stronger, and the wire was parallel, not series. Without electricity, the F-2 was comfortable down to 32 degrees Fahrenheit. With electricity, it kept the wearer comfortable at 30 below zero. The suit also had connections for heated goggles and an oxygen mask heater. Fixing other cold-related problems, the F-2 added thermostats in February 1944. Letting crews control heat instead of running at full power constantly. Crews had complained that original suits ran too hot in some conditions, causing sweating that froze and caused chill. The thermostats fixed this. The F-3 suit in spring 1944 extended comfort to -60, improved electrical controls and fittings, enhanced the parallel wiring. So even with multiple failures, the suit still provided some heat. But making new suits was only part of the solution. Manufacturing took time. Distributing them across the theater took more time. Training crews to use them took even more time. While the improved suits moved through the supply chain, men kept freezing over Germany. The second major improvement dealt with the wind blast problem. Gross investigation showed that wind blasting through the open waistgun windows was the single biggest cause of frostbite. Waistgunners were standing in 200 miles per hour Arctic wind chill at those speeds, and temperatures was more than the human body could handle. No heating suit or insulated clothing could stop frostbite from direct Arctic wind. The only real solution was to block the wind. The B-17G model began production in July 1943. After its first flight, It made the G model enter combat with the 8th Air Force in the fall of that year. It had enclosed waist gun windows. The guns were mounted through openings in plexiglass panels that blocked wind but still allowed the weapons to move and track targets. The new windows greatly reduced frostbite waste. Gunners who had been losing fingers could now operate in relative comfort. The cold was still there, but manageable by heated suits and clothing. The G model also staggered the waist gun positions. The left gunner was slightly forward of the right. This gave both men more room to move without bumping each other and reduced tangling of oxygen lines and heated suit cables that had caused equipment failures. Colonel Grow pushed for more improvements. Beyond suits and windows, he studied casualty reports and found specific failure modes causing injuries for each problem. He developed a solution. He designed warm, light, flexible gloves that did not need to be removed to clear jam. Guns of gloves used thinner, more flexible material, allowing precise finger movement. While still providing insulation, crews were trained that removing gloves would cause frostbite. They learned jam guns could usually be cleared with gloves if properly designed. He also created warm, fire-resistant face and neck protectors to prevent frostbite in those areas as hand injuries declined. He designed electrically heated blankets for wounded men whose suits had to be cut away if the aircraft heat system was destroyed or a wounded man's suit removed. These blankets provided warmth on the flight home. In July 1943, Grow received the Legion of Merit for developing body armor to protect combat crews. His analysis showed nearly 70% of combat wounds were from low velocity missiles, mainly shrapnel from nearby anti-aircraft shells. He designed light body armor with overlapping steel plates that stopped these fragments. The armor saved many lives and improved morale. In May 1944, Grow was awarded the Distinguished Service Medal for his work on crew protection. The citation mentioned his devices to protect gunners from wind blasts, his electrically heated clothing, gloves, boots, and hand warmers, his casualty bags for wounded, and his wind and fire-resistant face and neck protectors. Of recognition came because the solutions worked. Frostbite cases had dropped flight efficiency, improved crews, survived missions they would have lost the cold just months earlier. The statistics showed the change. In early 1943, cold injuries caused more crew losses than combat wounds. By late 1943 and into 1944, proportions reversed. Hand injuries, which had been more than half of all cold injuries through July 1943, fell sharply as better gloves and training reduced the need to touch frozen metal with bare skin. Face, neck, and ear injuries rose as hand injuries fell, but these injuries were less serious in manpower terms. A man with frostbitten ears could return to duty in days or weeks. A man missing fingers was permanently disabled. German intelligence noticed the changes. Luftwaffe pilots used to American formations suffering from cold now face a more effective enemy. Waist gunners who had been slow and clumsy from frozen hands could now track targets. Fully bald turret gunners who had been incapacitated by failed suits stayed in the fight the whole mission. The Germans saw the effects but did not know the causes. American offensive fire seemed more accurate. Formations looked more disciplined. Bombers that struggled from injured crews now stayed tight. Some improvement came from better fighter escort as P-51 Mustangs arrived. Some came from improved tactics learned through bloody experience, but some came from crews who were simply more effective because they were not fighting frostbite. While fighting the Luftwaffe, a gunner with working hands could track targets smoothly. A gunner with numb fingers could not. A crew with all positions manned by alert warm airmen could maintain defensive coverage. A crew with frostbite casualties could not. But the cost of learning these lessons was fingers, toes, and permanent disability. The first generation of 8th Air Force crews had been unwilling test subjects. They discovered through frozen flesh what worked and what failed. At 30,000 feet, Lieutenant John Luckadoo flew B17s with the 100th Bomb Group, known as the Bloody Hundred. Because of staggering casualty rates, the group suffered losses so severe that newer crews thought the unit was cursed. Other bomber groups avoided flying near the 100th, thinking their bad luck was contagious. The reality was simpler and more tragic. The 100 was not cursed. They were assigned to the most dangerous missions during the worst period of the air war. They flew deep raids into Germany before long-range fighter escort was available. They hit heavily defended targets. While the Luftwaffe was at peak strength, they paid the price for strategic decisions made far above their pay grade. Luckadoo completed his 25 required combat missions between June 1943 and February 1940 for one of the few men in his unit to do so. He flew through the worst period of the air war over Europe, when the 8th Air Force had no adequate fighter escort, when bomber losses were so high that statistically a man could not expect to survive his tour decades later, when Luckadoo was over 100 years old and the last surviving pilot from the original Bloody Hundredth. He spoke to audiences who could barely imagine what he had experienced. Crew members fought at 25,000 feet. He said they endured temperatures of minus 40 degrees Fahrenheit and survived on oxygen above 10,000 feet in unpressurized cabins prayers, and Luck-accompanied flyers on every mission. Luckadoo described the 4 challenges that defined every mission fighter's flak: frostbite, fear the alliteration, capture the reality of aerial combat. German defenders were only part of the danger. The environment itself tried to kill them. He recalled his own cold experience. My foot froze to a control pedal. He said, I had to land with my heels. I could not even apply the brakes. Temperatures were minus 50 to 60 below zero. The 8th Air Force flew from 40 bomber bases and 15 fighter bases across East Anglia, the rural agricultural region northeast of London, while the Royal Air Force bombed at night. The Americans flew the more dangerous daylight missions initially. Crews had complete 25 missions to rotate home. Airmen had about a 1 in 3 chance of reaching that number during 1942 and 1943. 2 out of 3 men would be killed, severely wounded, or captured before finishing their tours by the war's end. The 8th Air Force suffered over 40,000 casualties, with more than 26,000 killed. The death toll exceeded that of the United States Marine Corps for the entire Pacific War. The frostbite epidemic was part of that larger disaster. Preventable part: men died and were permanently injured because equipment failed, because training was inadequate, because no one anticipated how badly the cold would affect operations. Training programs in the United States had not prepared crews for high-altitude combat in European winter. Men trained in Texas and Arizona, where temperatures rarely dropped below freezing even in winter. They practiced at altitudes where cold was uncomfortable but not dangerous. They learned to use equipment in controlled environments where nothing went wrong. Then they arrived in England and flew their first missions into skies where temperatures reached 50 to 60 below zero, where the equipment they trained on failed under conditions it was never designed for, where everything they thought they knew about surviving at altitude proved inadequate. Some crews got extra training in England, but the 8th Air Force was desperate for replacements. Men were rushing to combat as quickly as possible. The gap between what they learned in the United States and what they needed to know in combat was filled by experience, and experience was paid for in blood and frozen flesh. The lessons learned in the frozen skies over Germany shaped military aviation for generations. When the Boeing B-29 Superfortress entered service over Japan in 1944, it featured fully pressurized crew compartments. The crew did not need electrically heated suits because the cabin stayed at survivable temperatures. The gun turrets were remotely controlled from inside the pressurized cabin, so gunners no longer sat exposed in the slipstream. The B-29 showed a new approach to high-altitude combat. Instead of protecting humans against the cold, it removed them from the environment entirely. The crew could fly in comfort, while the aircraft operated at altitudes that would freeze an unprotected man in minutes. This philosophy continued into the jet age. Modern military aircraft have pressurized climate-controlled cockpits. Fighter pilots wear flight suits mainly for G-force protection and emergency ejection, not for Arctic survival. The hard lessons of 1943. And 1944 taught designers a key truth: humans cannot survive extreme cold, no matter the protective equipment. Better to design the cold out of the equation. Every later generation of military aircraft follows this principle. Modern bombers and fighters maintain comfortable temperatures at any altitude or condition. Pilots face many dangers, but freezing is not one of them. The 8th Air Force bought that safety with blood and frozen flesh over Germany. The engineering changes also changed how the military thought about human factors. Before the frostbite crisis, designers expected humans to overcome limits through training and discipline. If the heating suit failed, train crews to cope. If gloves were too bulky, train crews to clear jams. Anyway, the frostbite epidemic proved is wrong. No training could let fingers work at 60 below zero. No discipline could stop flesh from freezing on contact with metal. The human body has physical limits that cannot be overcome by willpower. After the war, military equipment design increasingly included human factors. Designers asked not just if equipment worked, but if humans could use it effectively. Colonel Malcolm Grow continued his distinguished career after the United States Air Force became independent in 1947. The new Air Force Medical Service needed leaders who understood aviation and combat medicine on July 1st. 1949, Malcolm Grow became the first Surgeon General of the United States Air Force. He had helped create the service. He now led his work on crew protection, had saved countless lives, and established principles that still guide aerospace medicine. Grow retired from the Air Force on December 1st. 1949, after more than 31 years in uniform. He had served in 2 world wars. He had served in both Imperial Russia and the United States. He had pioneered aviation medicine. He died on October 20th, 1960 at age 72 at the Air Force Hospital at Andrews Air Force Base, and was buried at Arlington National Cemetery, too. Years later, the Malcolm Grow Medical Center at Joint Base Andrews was named in his honor, a permanent reminder of his contributions to military medicine. John Luckadoo, the last surviving pilot of the Bloody Hundred, died on September 1st, 2025 at age 103. He spent his final years telling the stories of the men who flew with him, making sure the world remembered what they endured. He also served as a technical consultant for the 2024 series Masters of the Air, ensuring a new generation would understand what his generation faced. The men who froze in the skies over Germany are gone now. The waist gunners and ball turret operators who endured minus 50 degrees cold for hours while fighting for their lives. The tail gunners and radio operators who suffered frostbite despite every piece of protective gear. Their generation has passed, but the experience of those frozen airmen shaped the world they left behind. Every pressurized cockpit, every climate control crew station, every piece of cold weather protective equipment used by modern aviators traces back to the failures and solutions of 1943. The frostbite epidemic was a preventable tragedy that became a force for innovation. Men suffered and died because equipment was inadequate. Their suffering drove the development of adequate equipment. That is often how military technology advances, not through research in comfortable labs or theoretical analysis by engineers who never saw combat, but through urgent, desperate need to solve problems that are killing people right now. Failure means death. Death motivates change. Change saves the next crew. The 8th Air Force lost more men to frostbite than enemy fire in the early bombing campaigns that should have been impossible, but became possible because the people designing equipment had never experienced what would face by late 1944. The problem was largely solved. Better suits with parallel wiring and closed waist gun windows, improved glove protective equipment, and systematic cold weather training reduced the frostbite epidemic from a crisis to a manageable challenge, but the price was paid by the men of 1942 and 1943, who discovered to their own frozen fingers what worked and what did not at 30,000 feet. Their sacrifice deserves to be remembered not as failure, but as adaptation and learning under the worst conditions they faced. Fighters flack frostbite and fear, and enough survived to teach lessons that would save those who came after. That is how innovation happens in war, not through committee specifications and procurement, but through sergeants and surgeons who see problems, find solutions, and refuse to accept that good men must keep dying from preventable causes. Colonel Malcolm Grow saw the problem, documented it, analyzed it, developed solutions, and pushed them through a slow bureaucracy. He saved lives that would otherwise have been lost. His name is on a hospital now, but his real monument is every pressurized cockpit, every climate control crew station, every piece of protective equipment that keeps modern aviators safe from the killing cold of high altitude. The men of the 8th Air Force brought that safety with their suffering. The waist gunners with frozen hands, the ball turret operators with dead heating suits, the tail gunners with frostbitten ears. They were test subjects in an experiment they never agreed to participate in. They discovered the limits of human endurance at minus 60 degrees. They paid the price so no one else would have to. We should not forget what they endured.